So today I want to talk about protocols and model. Protocols and model. There is no how you talk about networking without talking about protocols. There is no how you talk about networking without talking about models. And I'll start with protocol first. We're going to learn on model. Hopefully we should be able to get to that destination today, because these are part of the foundation that we are building in this course, in this program, CCNA training. We need to understand what a protocol is. So in layman's language, what is a protocol? You hear people say something like all protocol duly observed, or you hear people say, I am standing on existing protocols. So what are they talking about when they say all protocol duly observed, or I am standing on the existing protocol? It means there is an agreement. Before they started the meeting, there is a set of rules that governs that meeting, people's behavior, the way they talk, the agenda of the meeting, when they start the meeting, when they end the meeting. All of these are protocols. It's okay, like in this class now, we all agree to meet by 6 o'clock, Monday, Wednesday, Friday. You can relate that to protocol. Protocol is just a set of rules. Protocol is just a set of rules that guards our conversation or govern our conversation. And you're going to see a lot of things tied together as we proceed in this training. Because there's nothing you do on the internet, there's nothing you do on your computer that there is not a protocol working for that thing. And you're going to see as we proceed. That is my own way of defining it to you. Human being, we just say, I am standing on the existing protocols, or all protocol duly observed. So we are bringing it to networking right now. What is protocol? Set of rules. You see, protocol is just rules. Set of rules that govern communication. The rules that govern communication. So when you talk about the communication fundamental, one of the things that govern, that is part of the fundamental is this protocol. If there is no protocol, we cannot have orderliness. If there are no rules, no orderliness. For instance, now let's agree that we're going to have training. When? No agreement. What time? No agreement. Which date? No agreement. That means there is no protocol. You need to understand that, guys. So the rules, when you hear about protocol, let your mind go to rules, and not just rules, set of rules, because you could have different set of rules that govern a communication. So under this, we have communication fundamental. You can have different sizes of network. You can have different network, different complexity network. It's not enough to have all of these things, the connection, the devices, but they must all agree on how to communicate. Now, there are so many things going on behind the scene that you don't know or people don't know, but we are going to talk about some of those things as network engineers. This is one of it. Most people that use the internet, their own is just to on their data and use the internet. What is going on behind the scene, they don't know. But we need to demystify some things for you guys because you are going to be professionals. So the point we are making is this: before two computers can talk to themselves end to end anywhere in the world, they must have agreed on how to communicate, even though you are not aware. There are things in place that enables them to communicate end to end. It doesn't matter anywhere in the world. And that agreement, that set of rules is what we refer to as protocols. Same again, for any communication to take place, you must have a sender, you must have a receiver, and there must be a channel that will connect the two of them to communicate. That's another thing we need to talk about. One person cannot start talking to himself or herself. You know that there's a problem. There must be somebody you are trying to communicate. There must be somebody you are trying to send something to. So if we have two computers connected together like this, one of these two computers must be the sender, the other one must be the receiver, and there must be a medium for them to communicate, wired or wireless, physical or spiritual. We've talked about stuff like that. But even at that, with all of these elements that you're looking at, There is a protocol. But there are protocols. In fact, let me put it that because I'm going to be telling you different protocols as we proceed that will govern their communication depending on the communication they are having. Let me give you an example before we proceed. Anytime you are browsing the internet, there is a protocol that governs that. I'm sure you must have had HTTP or you have had HTTPS, especially this one. This is the protocol that governs browsing or web browsing. Anytime you are sending mail on the internet, whether you realize it or not, there is a protocol that governs sending and receiving of mail, majorly. SMTP, simple mail transfer protocol. Anytime you are downloading or uploading something on the internet, there is a protocol that governs that. It's called file transfer protocol. Anytime you are doing what we call a remote login, that is, you are logging into a device remotely, there is a protocol called Telnet, and there is another one called SSH. These are protocols that enables us to have remote login. You are advised not to use this. You should only use this. Which one is there again? Anytime your computer gets translated from domain name to an IP address, there is a protocol that governs that. It is called domain name system. What do I mean by this one? You people always type domain name. You say www.facebook.com. or you say www.yahoo.com. Computers don't talk with domain name, they talk with IP addresses. So something converts this name to an IP address, and I'm going to demonstrate that to you guys when we get there. So all of these things that I'm talking about, there are different protocols that govern different conversations depending on what you are doing on the internet. And it must not just be on the internet, just as we're used to internet. It could be local. Different protocols simply means different set of rules. And you know what? There are some protocols that work together to get these things done. We call them suite of protocols, or what is that word? Oh, interaction of protocols. And we're going to get to all of that level. So just follow me nicely. Okay, so 3 elements when you talk about communications. This is still under protocol. The rules is the same thing you're looking at here. Look at here. All communications, guys, are governed by protocols. All communications, whether you know or you don't know, you realize or you don't realize, all communications are governed by protocols. And so what is protocol? See another definition here. Protocols are the rules that communication will follow. Protocols are the rules that communication will follow. They are the set of rules that communication will follow. And guess what again? These rules will vary depending on the protocol. Let me break down guys. Protocols are the rules that communication will follow. But these rules vary on the protocol. For instance, now, if you are downloading, and this is the protocol that governs downloading, the set of rules for this will be different for the set of rules for HTTPS. Will be different from the set of rules on SMTP. So it depends on what we are trying to do. And all of these things are in place, whether you know it or not. Yours is just to do things, download things, browse, send mail, receive mail, all of these things you are doing. There are different protocols that governs all these activities. Don't ever forget that. I like this particular slide here. I like this slide. It's really summarized a lot of things for me. All communication are governed by protocols. Protocols are the rules that communication will follow. And these rules will vary depending on the protocol. Put it another way, this rule will vary depending on the kind of communication we're having. Because you can have different communications or different topics. For instance, now we're having a class here. All our discussions on IT. So what if we switch to politics? That's another topic entirely. So there will be a different set of rules that will govern that our communication. So don't ever forget this slide. This particular slide is it's a bomb. All communication are governed by protocols. And don't forget what protocols is. Protocols is just a set of rules, or protocols are the rules that govern that communication will follow. And these rules will vary depending on the protocol. Take note of that, guys. So back to protocol again. Protocol again. We have a lot of things to talk about here on protocols, and then we're going to tile them all as we proceed. I need you to take note of this, guys. Network protocols. Why they say network protocols here? Why they say network protocols? Just follow me. We're going to get there. Network protocols define a common set of rules, and it can be implemented in software, in hardware, or both. What are we talking about here? The people that build software, there are things they build in software that has to do with protocol, set of rules. The people that build hardware, there are things they put in hardware, and hardware in this context now, we're talking about networking hardware. And software in this context, we are talking about networking software. When I say networking software, I'm talking about TCP/IP, something like TCP/IP, and so on and so forth. So what these protocols we are talking about, it's not just about application, or it's not just about software. For instance, now I am running Windows 10, or sorry, Windows 11. There are things inside this Windows 11 that will enable me to communicate or to connect to the network before I can start browsing the internet. So there will be protocols that will govern that my connection to the network. So many things in place, but the one we are concerned about is the one that has to do with network. And you see what will help us to break them down. So network protocols define common set of rules, whether we implement in software or we implement in hardware. When I say implement in software or hardware, I'm talking about the vendors, the people that manufacture these things. Not you and I, we are just end users. But because we are network engineers, we need to understand some things that goes on behind the scene. So when I go to my laptop, for instance, now, and I want to connect to the internet, what are the things I need to do to connect my laptop to the internet? I need to connect a network cable, or I need to connect my laptop wirelessly. Please don't distract me. Abubakar is sending a message. Nobody should type anything. Don't distract me. If you have any issue with network, when we are done, you can listen to the video later. We have said this again and again and again. Nobody types anything. When you type something like that, you distract me. If you have issue, then when we are done, you watch the video on YouTube. No, I lost my thoughts now. So I'm trying to grab it back. Let me start again from here. Network protocols defines a common set of rules. Okay, I was trying to say, so we are just end users. Okay, I say, let's assume I want to connect my laptop to the internet, for instance, now. I need to connect a network cable, or I need to connect to the Wi-Fi. But you and I know there is no other system will browse if the system does not get an IP address. My computer must have an IP address. That's part of the protocols we're talking about, because this IP is called Internet Protocol. TCP/IP must work on my laptop, must be activated. It's another set of protocol, and we're going to come to all of these things later. So there's so many things in place before we can connect to the network, browse on the network, download on the network, send email. So many things are going on behind the scene. And most of these protocols we are talking about, they're implemented in our operating system, implemented in our network operating system. That is the operating system that runs in our network devices. They are implemented in almost everything that's part of our network connection, or let me say component, whether it is hardware or in software. Set of rules. Okay, when your switch want to communicate to another switch, or when your switch want to pass a message to somebody that is connected to the switch, what kind of rule will the switch be following? There's so many things put in place. But with the one that are very important to us are the only one we're going to learn in the class. So listen to this now. Protocols have their own function, formats, and rules. There's a thin line between all of these things, especially formats and rules. So it simply means when there is a protocol, what did we say about protocol? Set of rules, guidelines that everybody must follow. So what is this? What are the rules? What are the format of the rules? What are the rules meant to do? So every protocol you talk about, they have set of rules. They are set of rules. They have their own format and they have their own function. It's like now, if you are traveling abroad, if it is winter, what are you supposed to do? Buy jacket, dress properly, wear socks. Well, that's more or less like telling you what to do, set of rules or dress code. That's the format. And when there's no winter, when the winter is gone, nobody will tell you before you get rid of those things. Another set of rules will kick in. So every single thing we do on the network, there are different rules that govern what we do on the network. And you're going to see as we proceed, whether on network communication or generally, or on network security, or on routing, or service discovery, there are different rules that govern different things ongoing on the network. You are going to see how we tie this thing all together. So let's move on, guys. Okay, so look at this, what we have here. I'm going to summarize this part. So somebody is sitting down here. You need to have something to do with this server. He's sending a message to the server, and of course, the server has to respond. So what is the big deal about this conversation? This guy must have an IP address. It's a protocol. He said, I'll send this message across the network using an IPv4 header. That is, he must have his own IP address. Where the message is going to, the server too must have an IP address. So how will this router on the road to that destination know where the message is going to? The router has what is called a routing table. It knows the location of every other network around that router. And then the router can make decision. When the man sends the message to this router, they make up their mind or make up the decision whether to follow this path or to follow this path. A number of factors will determine that, we influence that. And then, of course, the message will get to the destination. So how did this happen? A lot of things were involved along the line. A lot of things. E.g., look at what we have here. I like this. Devices use agreed upon protocols. Look at this again. Devices use agreed upon protocols to communicate. We've said that one before. All the devices on the road to destination, they all have the same things in common. They all have agreed on something. And all of them is this protocol of it. It's a set of rules. If anybody breaks the rule, there will be a problem along the line. So look at it. In this protocol, in this set of rules, these are some of the things they will agree on addressing. How do we address the devices on the road to from source to destination? Reliability. Who provides the reliability? We're going to talk more about it. Flow control. Flow control is like, okay, if I'm going to push data to you, at what rate should I push the data? What can you take per time? Sequencing, how do I label the messages that's coming from me to you, so that when it gets to you, you will be able to unwrap them and put them back together. We have a chapter dedicated to all of these things. Error detection. If there is a problem on the road with my data, if it's corrupted during transmission, how do I get to know about that? How do I get the information that that message got corrupted along the line? Oh, this is part of what we are going to agree on. And then application interface. How are we going to have end-to-end communication at the application layer? And we're going to talk about the application layer briefly into this class. These are things, some of the things that will be agreed upon between all the devices along the line to the destination. And that is why they put this ones under network protocol functions, because it's more or less about maybe network devices from source to destination. But I don't want to just use that word network protocol alone. I want to be restricted to protocol. And then later on, you're going to see the reason why I don't want to use that word network. Because there are different protocols at different layers of the OSI model. And we're going to talk about OSI model briefly into this class. So take note of that. This is another thing I was trying to tell you earlier. Protocol interaction. What do you mean by protocol interaction? When I mentioned HTTP at the beginning and say whenever you are browsing the internet, you are using HTTP or modern day recommendation or best practices, it must be HTTPS, secure HTTP. Class rep, can you hear me? If you can hear me, give me thumbs up. Okay. Once I see their thumbs up, anybody that cannot hear me, that means it's from your own hand. So class rep, please, once you see somebody saying they can't hear me or they send tortoise, just respond with thumbs up if you can hear me. Uche, you can also help me too. Thank you guys. Samuel, you can help me too, so that I don't get distracted. Thank you, Sunday. So now, I was saying something earlier. I said, whenever you are browsing the internet, HTTP is what is governed, HTTP or HTTPS. Of course, it is recommended that you use HTTPS. I say whenever you are browsing the internet, I mean, you are downloading or uploading, you use FTP. Now, when I say you use, I'm not saying you are the one to indicate that this is what you want to use. I'm just talking about the protocol that governs the things behind the scene. You are not aware. When you send mail, we have SMTP. It's the most popular one. There is POP3 and I think POP and POP3 also. So now, all these protocols I mentioned earlier, like DNS, I mentioned DNS, they cannot exist all by themselves. They cannot exist all by themselves. HTTP needs to rely on top of TCP. TCP needs to rely on top of IP. And IP needs to rely on top of Ethernet. And all of these things together is what we call interaction of protocols. She said, this guy is speaking in tongue. Don't worry, I will break it down. I will use OSI model to break this thing down for you. Because HTTP operates at layer 7. TCP operates at layer 4. IP operates at layer 3. Ethernet operates at layer 2. All of these layers or protocols at these layers must work together. If there is no IP, HTTP cannot do anything. If there is no TCP, HTTP is useless. So all of these foundational protocol must be in place. They must be doing their own before HTTP can get to work and do its own work. And the reason why we call them interaction of protocol is all of these things happen concurrently. It's not as if Ethernet will happen separately, IP will happen separately, TCP will happen separately, then HTTP. No. All of these protocols will work together to get the job done, and that is what we call interaction of protocol. So just take note of that. By the time we come to OSI model, you say, I'm going to tie all of these knots together. So for HTTP to get its job done, it must rely on TCP. For TCP must rely on top of IP, and IP must rely on top of Ethernet. And this is what we call interaction of protocols. And by the time we come to OSI model, I'm going to now demystify them one after the other. There's no point wasting time here since we are still going to talk about this thing on the application layer, transport layer, internet layer, then data link layer. There's no point. Just take note of this. This is what we call interaction of protocol. So you see the job of HTTP. You see the job of TCP. You see the job of IP. You see the job of Ethernet. There is a chapter dedicated to this application layer. We are going to talk not just HTTP, application layer and application layer protocol. There is a chapter dedicated to transport layer protocol. That is where we're going to talk about TCP and of course on UDP. There's a chapter dedicated to internet layer. That is where we're going to talk about IP and some other protocols. And there's a chapter dedicated to data link layer. That is where we're going to talk about Ethernet and some other protocol at that layer too. So don't worry, we're going to come to that. But you just know that those protocols that I mentioned earlier, they are all called application layer protocols, but they cannot survive all by themselves. They need to rely on other protocols like TCP, like IP, like Ethernet. So for now, just copy and paste. When I say copy and paste, just quote me that I said this. Explanation, details to come later. One of the things I love about networking is when we teach things and we start making use of that knowledge in the field, or students start making use of the knowledge and they call you and they tell you how things are working. I told you now, this thing we've been here, we've been around for a long time. We know how this thing works. So trust me, I'm going to connect all the dots. Just be patient with me. Some of the dots will not be connected today until our next class. Some maybe the second class, the next two classes, or the third class. By the time we are done with all the OSI model, you are going to get a full picture. Yeah, that's another good way to put it. A full picture of what we are talking about. So when you hear interaction of protocol or protocol interaction, it's simply telling you that there are different protocols that work together, and all of these protocols operate at different layers of the OSI model, which we are going to talk about briefly in today's class. Same thing as protocol suite. When you talk about protocol suite, it's still a group of interrelated protocols. So all of the things I've talked about in this previous slide is the same thing here. Look at what they said here. Protocols must be able to work with other protocols. Protocols must be able to work with other protocols. It's still the same thing as interaction of protocol. So when you hear protocol suite, well, it's the same thing. It is a group of interrelated protocols necessary to perform a communication function. Now look at this definition here. Set of rules that work together to help to solve a problem. Different set of rules at different layers. So when you hear talk about the interaction of protocols, protocols work together. Suite of protocol suite is still a group of interrelation protocols working together. And there are some protocols that are called upper layer protocols. Some protocols are called lower layer protocols. Still going back to OSI model, which we are going to use to explain this concept. Part of what you get done in protocol set of rules is look at the good example here. This guy wants to talk to this guy here, and at a particular layer called layer 1, they are having some conversation. But before they start that conversation, they have decided to use a common language. I'm speaking English. Imagine you people are Germans and you don't understand English. Then we're in trouble. I need an interpreter. Then I signal to the guy, wait for your turn. This is how you know that I'm done talking. And wait for your turn. Then I will signal when I'm done talking. Then you can talk. So many things to agree on. And that's why things are working on the internet or on the network. If there are no protocols behind the scene, things will fall apart. Nothing will work. Imagine I am saying good morning and you are hearing good afternoon. Or I'm saying good afternoon, you are hearing good night. Because there are no protocols in place. So there are a lot of protocols behind the scene. And we're going to use OSI model to break them down. And then we relate that to TCP/IP model. That will be when we get to that part of our training. So still the same thing. So some of these protocols are called upper layer protocols. Some are called lower layer protocols. So which protocols are called upper layer? Which protocols are called lower layer? You're going to see when we get there. So part of what we're going to talk about as we proceed, we're going to talk about TCP/IP model. We're going to talk about OSI model. So these parts, I'm still not going to talk about this part here. So now look at one of the things I was telling you guys earlier. Different layers to talk about later. We have what we call application layer. We have transport layer. We have internet layer. And we have a layer called network access layer. All of these layers you are seeing, they are under TCP/IP model. TCP/IP model, which we are going to come to later. Now, at the application layer, look at all the protocols under TCP/IP. Look at all the protocols under ISO. Look at all the protocols under AppleTalk. Look at all the protocols under Nove. But you know what? All these protocols, all these ones we are looking at, they are dead. All these ones you are looking at, they are dead. When I say they are dead, school, their legacy, nobody is using them again. We're only concerned about this part here and this part, of course. We're only concerned about things under TCP/IP. So at the application layer, look at different protocols that we're going to talk about. HTTP, DNS, DHCP, FTP. At the transport layer, look at the protocols we are going to come and talk about. TCP, UDP. At internet layer, we're going to talk about IP version 4, IP version 6, ICMP version 4, ICMP version 6, and of course at network access layer, we will talk about Ethernet, we will talk about the address resolution protocol, and of course we're going to say some things about wireless LAN. All of these things are well interpreted when we use OSI model. When we use OSI model, they are well interpreted. So we're going to come to that. So when they say evolution of protocol suites, we're going to tie it to TCP/IP model. We're going to tie it to OSI model. So whether we are talking TCP/IP or OSI, both of them are called a reference model. And why do we have reference model? What is the reason for that? Why? Why do we need that? We're going to come to that. But let's sort out the issue of protocols first before we go to reference model. So a lot of repetition here. I've talked about HTTP run on top of TCP, runs on top of IP, runs on top of Ethernet. These are called international protocol. They work together to get the job done. Same thing here. Those are the expatiated. Give us more protocols at the application layer. More protocols are, two protocols are transport layer and one is connected. The other one is connectionless. We're still going to come to that. Protocols at the internet layer and protocols at network access layer. All of this, we are going to come to them when we take each of these layers one after the other. Just like I said earlier, I have a chapter dedicated to application layer. I have a chapter dedicated to transport layer. I have a chapter dedicated to internet layer. And then part of this, I have a chapter dedicated to data link layer, but you see how we're going to connect it when we come to that place. So I don't want to repeat myself, say it here, and when we get to that part, we are going to say the same thing again. So these are all the things I need you guys to understand. Here again, we're still saying the same thing. What do I mean by that? So when message starts from a particular person and is going to the other side, what are the things we are going to see if we capture the data along the line? It's still what we have been talking about. You will see the real message, which is part of the bigger picture. Just don't worry. When we come to each of these layers, you see them there. The real data, you will see TCP in action. You will see IP in action. You will see Ethernet in action. And of course, our message, of course, will be converted to zeros and ones. These we are going to take care of when we come to OSI model. So that is why they are saying a client, a web server encapsulate and send a message to the client. Sorry, is this server that is sending? So what happened to the client? A client de-encapsulates the web page. I'm going to talk about this when we come to OSI model. Encapsulation and de-encapsulation. What do you mean by encapsulation? What do you mean by de-encapsulation? All of this we're going to talk about when we come to OSI model. Okay, I think the last part here is standard organization. What do you mean by standard organization? You need to know this. At the beginning of networking, there were issues with interoperability. What do I mean by that? When they first started networking, if you are using Dell computer and I am using HP, HP cannot talk to Dell, Dell cannot talk to HP. Dell can only talk to Dell. HP can only talk to HP. Lenovo can only talk to Lenovo. There were issues at the beginning of networking. People were just doing what they like. You do it your own way. And it's not only about Dell, even network devices. The vendors come up with their own devices that can only work for them or work with their own set of devices. So they have these bodies called open standard body. They have to come up with standard. When we say standard, a kind of a rule or something that everybody must follow in order for us to have interoperability. So we have IEEE, they are part of the open standard. IEEE, part of the open standard. Thank you, doctor. IETF, part of the open standard. ICANN, ITU, all of these people came up together and said, no, we cannot have a world where Dell can only talk to Dell, HP can only talk to HP, all these computers. So what happens? Everybody will just be doing what they like. It's like when you want to cook a soup now. We now come to an agreement and say, just put salt, put pepper, and put onion. Any other thing you put, no problem. It's the same thing. They came up and said, okay, if you want to network, if you want to build a network device, put this, put this, put this. Others cannot connect to you, regardless of the machine they are bringing, or computers they are bringing, or other devices they are bringing. If you want to network, if you want to build a network card or manufacture a network card, put this, and put that. It doesn't matter who uses it in the world, it's going to work. These are all the things they came up with inside this open standard. And they were the one that gave us this so-called reference model we're going to talk about at the end of the class today. So what do we stand to benefit from open standard? Interoperability. Interoperability. Bring up your Dell, bring up your HP, bring up your Lenovo. It makes no difference. Anything can connect to anything. Even a tablet can connect to the network. We enjoy interoperability. We enjoy interoperability. And as a result of that, you have competition because you build your own network device, since you understand all of this standard, you can make it better than other people's own. Other people can make their own better than your own. And of course, you also enjoy innovation because all you need to understand is just the fundamentals, and then the rest is in your hand. So open standard encourage interoperability. That is the most important thing we got. So you can go and buy a Cisco switch right now and buy another switch that belongs to another vendor, let's say Huawei, and you link them up together and connect people here and connect people here, and there will be communication. There's no fight. There is no, I don't understand you. There's no disagreement. Everybody, all the devices in the world can interoperate. On the internet, there are Cisco routers, there are non-Cisco routers, there are Juniper routers on the internet, and all of these devices are talking to themselves. This was only achieved because of interoperability, which these bodies give to us. So we don't bloody care about the vendor again. No barrier, no restriction. I like the way this person put no barrier, no restriction. So open standard help our world to achieve what we have today. So these bodies were behind all of these things. Now, if you want to know, for people that read electrical electronic, they know details about this body. I think IEEE have been around for a long time. Anything that has to do with, like, for instance, NITEL, all their cabling, all their equipment, standard for those things, they are involved in all of those things. And other body like IETF, Internet Exchange Task Force, they are also part of the Open Standard Organization. Or let me say standard organization. Let me not keep on adding open. Standard organization, they come up with the standard, what everybody must follow. And you need to understand this, guys. You need to understand this. So we're still going to come to that. We're going to come to that. So the last part I will be talking about is the reference model. Reference model. So what is this reference model all about? These people we talked about earlier, when they came up to talk about standard, they now gave the word a model, and that model is called reference model. And under that model, we have what we call OSI model, our TCP/IP model. We have two models. One is OSI model. One is TCP/IP model. These are competing models back in those days. OSI came before TCP/IP. So what is the big deal about these models, guys? Let's talk about OSI model first. So when these people came together, they were like, can we explain the flow of data to people? Can we explain the flow of data? So when people understand how data flow, they can now program an application that will be part of the network or that will be accessible over the network. Manufacturers can manufacture things that will be accessible over the network. Let them just understand the flow of data. So in trying to explain to us this flow of data, they came up with OSI model. What is in the OSI model? There are 7 layers in OSI model. And look at the layers here. We have application layer, we have presentation layer, we have session layer, we have transport layer, we have network layer, we have data link layer, and we have physical layer. And at each of these layers, you will see what your data becomes. You will see what happens to your data as we proceed in the class. Not today. Today is just an introduction to this. At each of these layers, for instance, you as the end user, when you sit down on the computer like this, you are interacting at the application layer. You are at the application layer. You as a user. Anytime you sit down on your system to do one or two things, you are see your interface with the network, you are at the application layer. So whatever you do at that point in time with your data and push it like this through the network to go through the other side, it must pass through all of these layers. The data will be going down from application layer to presentation layer to session layer to transport layer to network layer to data link layer to physical layer. That is the flow of data. Now let me tell you something before I continue. For instance, your data is called data at the application layer. Your data is still called data at the transport and presentation layer. Your data is still called data at session layer. But the moment your data gets to transport layer, we don't call that your data, we call it segments. Why? You will know when we get to transport layer. The moment your data get to network layer, we call your data packet. I'm talking of OSI now. The moment your data get to data link layer, we call your data frame. And guess what? The moment your data get to physical layer, we call your data bits. Your data becomes zeros and ones. And this process here, from top to down, is what we call encapsulation. We're packaging the data to be able to move over the network to the other side. So if I am seated here, let's say this is me, and then this is class rep, wherever class rep is, and I want to talk to class rep, let's say there's a switch in between, and then it's a router, and then connected to another switch in between. Before I can message whatever I want to push to the other side to the class rep, it has to go through the process of encapsulation. That message has to be converted to zeros and ones, which you call bits. Zeros and ones, that is what we call bits. You know, computer does not talk our language, guys. You need to know that. Computer talks in binary, zeros and ones. As I'm talking to you guys right now, I am vomiting millions and millions of zeros and ones. But what is happening from my hand and from your own hand? Computer is encapsulating it. Pass over the network. The encapsulating on your own hand there, and you are hearing everything. So when it gets to your hand, because you don't speak binary, computer has to package everything back to what you understand on the other side. And that is called encapsulation. So, I mean, the encapsulation. Encapsulation happens from my own hand as the source or the sender. The encapsulation happens on the other side. We are going to come to more of this later. So what I'm trying to say in essence is this. These people, this standard organization, they gave us this reference model. And in this model, for OSI model, there are 7 layers. And this is just for us to understand the flow of data. How data flow or what happens to data at each of these layers. And this is just to help the programmers or to help the manufacturers when they manufacture or program anything that needs to be accessed over the network. But OSI model did not last. By the time they came up with what became the internet today, OSI model lost the battle to TCP/IP model. So in our class as we proceed, you are going to see that we're going to be talking in between OSI model, TCP/IP model. Sometimes we talk about similarities. Sometimes we talk about differences. Sometimes we use them interchangeably, and you're going to see as we proceed. So what exactly is this TCP/IP model? You know what? TCP/IP model is just a modification of the OSI model. And the internet of today, the network of today, built upon OSI model. It's built upon TCP/IP model. I beg your pardon. The network of today, the internet of today, is built on top of TCP/IP model. So what did they do? They bundle 3 layers together. The powers that be gave out to 1 layer of TCP/IP. Transport is still transport, guys. Network layer, they change the name to internet layer, and they bundle the remaining layer model together to give us just 1 network access layer. So network of nowadays, internet of today, everything built on top of TCP/IP model. But we still use OSI model in the class to discuss. Why? The layers are more detailed, and you will see as we proceed. But you must be able to differentiate between the two and you must know the similarity. The two of them are just explaining the flow of data. So as we proceed in this class now, I have a chapter dedicated to application layer. I have a chapter dedicated to internet transport layer. I have a chapter dedicated to internet layer, even though we call it network layer. And guys what? I have a chapter dedicated to data link layer. I have a chapter dedicated to physical layer. So this is one chapter, two chapter, three chapter, 4, 5. 5 different chapters to drive this my point home. So you know it's a long journey, guys. When we come to our next class, I'll try to take physical layer and data link layer together. Another class, I'll take network layer, maybe with transport, depending on how big the PowerPoints or what we have there. But throughout next week, I must finish everything that has to do with OSI model or TCP IP model. So we're still going to be bringing this thing, expanding these things as we proceed. But this is just a summary for you to see. The people that came up with these things, they gave us reference model. And in this reference model, we have layers. And that's why they call it layer model. This reference model is also a layered model. Layer model. So what is it in doing for us? Is just to understand the flow of data or to describe network operation. I prefer flow of data, how data flows from source to destination. So since we are not programmers, guys, and we are not manufacturers, why do we need this knowledge? I can bet it with you. If you understand this thing very well, there are some things you will troubleshoot in networking. In IT is look for trouble and shoot it, meaning you find a problem and fix it. Troubleshoot. Look for trouble and shoot it. What is troubling the network or your network? Look for it and shoot it. Troubleshooting. That's my own way of explaining it. You look for the problem and solve the problem. When you understand, for instance, the OSI model now, if you understand it very well, you can be working on the network somewhere and you tell me you have a problem. So it's a layer 1 problem. And this is our layer 1. Or you're working somewhere and you tell me there is a problem, and so it's a layer 2 problem. Or I say, no, have you checked layer 3? Or is layer 3 in place? Or I tell you it's a layer 4 problem. Or I tell you it's an application layer problem. So we use this to solve problem on our network. Another way I can put this to you is this. When we're building the network, when I say building, we are trying to maybe a new contract, a new project. You're trying to build the network. We started the journey from layer 1. You're going to see from our physical layer, anything that has to do with cable, we make sure it's intact. Then we'll move to layer 2. Then we'll move to layer 3. Then we'll move to layer 4. Of course, the last part is the application layer. So for us as network engineer, this layer is very important to us when we are building the network. Take, for instance, now, you build a network and your physical layer is not intact. It's not good enough. What I mean by that, the cablings are bad. For instance, some of the jam centers, CBT center in the country, at the beginning of their jam stuff, that was their problem. The people had issue with layer 1. So if layer 1 is faulty, forget about layer 2, forget about layer 3. If the foundation is destroyed, what can the righteous do? That is what layer 1 is to us. If layer 1 is faulty, there's nothing you can do. There's nothing you build on. It's like foundation. If your foundation, the foundation of your house is faulty, don't mind me. If the foundation of your house is faulty, there's nothing you can do about it. That house is going to crack later, or it's going to start having issue later, and so on and so forth. So my point is this: don't throw away this OSI model or reference model because you think, after all, I'm not a programmer or I'm not a manufacturer. It's meant for those. We also use it when we are troubleshooting because it's a reference model for us to build network. It's a reference model for us to troubleshoot network when there are issues. And you know, sometimes we have issue with the people that are programmers in the organization. They are pointing finger out to us. We are pointing finger at them. We need to be able to tell them that, guys, we have done all the part that has to do with us. We have tested our layer 1 is intact, our layer 2 is intact, 3 is intact, 4 is intact. Every other thing is for you programmers. So if things are not working, we throw the blame at them. Because sometimes there's a blame game between the what's that they call programming units and the networking units. When some things are not working, they say, hey, it's the network. It's the network. The application is running fine. Then the network engineers will have to say, no, it's not our network. Layer 1 is intact. Layer 2 is intact. Because we have different ways to test all of this. You're going to see as we proceed. Layer 2 is intact. Layer 3 is intact. Form, no shaking. It's your problem. So this is also important to us, guys. So don't worry as we proceed. That will be from our next class. We're going to now begin to pick. We're going to go into detail. I have a video recording I did for some guys in Kano. I think I will look for it. So that will give you a summary of what I'm trying to teach you guys as far as OSI model is concerned. I will look for that video and post it. Just that the video is not edited, so you probably will hear me asking them questions, calling names, and all of that, you know. But I think it will bless some people. If you can listen to that video ahead of time, that's the way I taught that class. It was just a summary of everything, not the way I'm teaching your own chapter by chapter. I pick all the models, do one OSI model on the left, another one on the right, and I put the two of them side by side, and I started explaining them to the student. So this phase of this training, you guys need to understand this layer model. You guys need to understand reference model and the application. The application to us as engineer, I've just mentioned some things to you now. But there are so many things going on behind the scene. Once you understand most of these things, I bet with you, if you want to do cybersecurity, if you have some strong foundation at this level, it will be very easy for you. The other day, somebody has a question about MAC address. What's the difference between MAC address and IP address? That's a part of the things we use OSI model to explain. MAC address reside at layer 2. IP address reside at layer 3. If I can trace you as a bad guy to layer 3, I need to be able to follow you further to layer 2 to know your location, to know your house. Because my IP address is more or less like showing you the street. MAC address is like, if an IP address is like show me your compound, MAC address is like show me your room where you live. And all of these things still fall back to OSI model. So a lot to talk about OSI model. So take note of that. Let me see what I have. So you see the benefit of OSI model. This is part of that standardization we're talking about. This is how they achieve it. They use a layer model to achieve that standardization. So when people understand, oh, this is how data flow, so they are able to put this in place to enhance interoperability, to have a common language. All of those summary we've talked about at the early stage or at the beginning of the training. When we're talking about standardization or standard organization, that interoperability, the way the people are able to achieve it is by using reference model or by using layer model. And all of this is you're going to see. Look how all the layers here again. OSI reference model. We have physical layer, we have data link layer, we have network layer, we have transport layer, session, presentation, and application. And you see the summary on this page here. We have separate chapters to each of these layers, and we are going to come to all of that later. This is the TCP/IP reference model. Don't forget I told you TCP/IP reference model is a modification of OSI model, and that is what gives us the internet of today. And this is the summary again here. You see the bundle 3 models together here, 3 of these models to give back to this. Of course, they didn't change the name of transport. They changed the name of network to internet. And then, of course, they bundled the remaining 2 layers together of the OSI model on the lower layers, we call them, and they call their own network access. Now, whether we are using OSI model to teach you or we are using TCP/IP model to teach you, all of them explain the flow of data. Just that we prefer to use OSI model as network engineers because it's more detailed to us. When I say more detailed, some things happen at layer 2. We don't want to mix it up with what is happening at layer 1. We want to separate them in our discussion. That was the mess they created with TCP/IP. If they had left these layers alone, separate, OSI model will be dead by now. So they call their own network access. So there are 2 things going on there. Layer 2 issues are going on. We have layer 1 issue. We don't want to mix them up. Somebody, Asidu Baba, I don't like the way you are doing